The power analysis application on the scope provides a comprehensive set of measurements that goes far beyond the ordinary measurements available on the instrument. These measurements include such line-side measurements as power quality and harmonics, and some switching regulator side measurements including switching loss, ripple, modulation, and safe operating area. In this video, we'll take a quick look at three of the most common measurements: power quality, switching loss, and harmonics. Measurements made in power systems are often non-ground referenced, or they're floating measurements, such as measuring the voltage across two terminals of a device or measuring the current through that device. This often necessitates the need for using differential probes and current probes. Now, there are a couple of procedures when using these probes that are very important to ensure accurate measurements. The first is to auto-zero the differential probe. Short the two leads together, bring up the probe menu, and select auto-zero. The next is to properly auto-zero and degauss the current probe. Upon plugging the probe in, you will get a message that tells you to degauss the probe. We'll close the jaws on the probe, bring up the probe menu, and hit the degauss auto-zero. The final thing we want to do is equalize the propagation delay between the probes by deskewing them. This is particularly important for high-frequency switching voltage regulator measurements because a small amount of skew can lead to relatively large errors in measurements. Special deskew fixtures are available that allow you to connect the probes up and adjust the delay or skew of one probe with respect to another. But if you don't have such a fixture, you can use the recommended deskew values that are indicated in the table by just selecting that from the menu. The power quality function characterizes our system's power draw from the line. It's important to define the inputs of where the voltage and current are being applied. You can determine which measurements are displayed, and also select which input is being used as the frequency reference. The power quality results include the RMS value of the voltage and current, the crest factor for the voltage and current, including the true power and apparent power and power factor, and other parameters. The harmonics measurement gives a measure of the harmonic content of the power drawn by our system. And again, you can define the inputs and also test to various standards, including IEC 61000-3-2 and MIL standard 1399. The setup key will allow you to measure harmonics for the current or the voltage and the number of harmonics to take a look at. And the display allows you to control whether we want to show the harmonic results graphically or in a table. And oftentimes we're most interested in just the even or odd harmonics, so we can actually choose to look at just one or the other as opposed to all of them. When testing harmonics to a given standard, the setup key allows you to change the parameters and limits per that standard. The switching loss measurement allows us to characterize the amount of power dissipated in the commutating or switching element of a switching regulator. In this case, we are probing the drain to source voltage of an IRFZ44 power MOSFET and the drain current flowing through that device during the switching operation. We'll put a couple more cycles on the screen and turn on the switching loss measurement. The results show the power lost in the device as it's being switched on and as it's being switched off, and the power lost in the device while it's conducting. The conduction loss is computed by multiplying the current through the device by the voltage during the on time. This voltage during the on time can be quite small. Measuring this accurately can be problematic when dealing with relatively large voltage scales. Using high-res sampling can certainly help this. But in addition, there are several other conduction calculation methods that can be used. If you know the RDS on of the MOSFET being used or the saturation voltage of the bipolar transistor being used, you can dial that in and have it compute the power based on that. So for example, if we know that the RDS on of this transistor is about 30 milliohms at the voltage that we're using it at, we can use that and have it compute the conduction power loss based on that. The power analysis application, along with differential and current probes, provide a comprehensive set of measurements to help you characterize the performance of your power system.
Find out more at Vicom's website.